Hello, algebra students. Let's talk about undefined expressions. Basically, think of it like a problem that has no answer. Let me explain. So, first example, the quotient of any number, quotient, remember that's our language from basic algebra there, means we're dividing. So the quotient of any number divided by 0 is undefined in the set of real numbers. Okay, what am I trying to say? I'm trying to say that if you take a number, any number, I'm going to just use 7 as a simple example, and divide by 0, you don't have a real answer as you guys tend to think of it. I can't simplify this because I don't know what 7 divided by 0 is. It's not an answer. It's undefined. Now, careful though, that's not the same as 0 divided by 7. You know, I can take nothing and divide it into 7 pieces. We'll just all end up with nothing. But this first example here is like think of it like taking $7 and dividing it up into 0 groups. Like, how do you divide into 0 groups? You could divide and divide and divide for the rest of your life into groups of 0, and you'll never use up the 7. All right, so undefined if you divide by 0. All of that to say that if you look at this particular expression, even though it might look complicated, it's just a fraction. And whatever's on the bottom, that denominator is what we're dividing by. And so what that practically means to us is that this denominator, if it equals 0, then the expression is undefined. Kind of gives like a false answer, one way to think of it. So let's go ahead and look for one of these multiple choices here that turns the bottom into 0. Now, I'm so lazy, you guys. Like, I could test every one of these, but look at this. This is in parentheses, x minus 1, times something else in parentheses, 3 minus x. And so I know that if I take a number and multiply, I want to multiply 2 numbers, the only way to get something that equals 0 is if one of the numbers is 0. So like either the first number is 0 or the second number is 0. That would multiply to give me 0. And so I'm going to use that little fact here in order to look at one at a time. So imagine how I would make this particular part of the denominator 0. Well, if I had 1 and I take away 1, that makes 0. Let me show you what I mean. 1 minus 1 times 3 minus 1. If I had 1 minus 1, it'd give me 0. And then 3 minus 1, of course, is 2, but 0 times 2 is 0. And so plugging 1 into that sucker would make the whole thing equal 0. So definitely one of these guys with a 1 in it. Now, how about the next one, though? 3 minus x. How could I make that guy equal 0? Well, 3 minus 3 equals 0. So if I turned x into 3, I'd get 3 minus 1 times 3 minus 3. And of course, 3 minus 1 is 2, and 3 minus 3 is 0. And so 2 times 0 is 0. So also 3. So now I'm liking A, B, and C. Sorry, but I need to check this 7. And this is where you really need to watch out, okay? Because it looks like 7's tempting, because if I look up at the top of this fraction, 7 minus 7 is 0. Hey, but remember, we're allowed to have 0 on the top. You can divide 0 by a number. You just can't divide a number by 0. And so this is just there to fool you. Correct answer is B. All right, B has 2 numbers that would have made the denominator of this fraction equal 0, which would make the entire expression undefined because we can't divide by 0. Now, look at the next example. It says the square root of a negative number is undefined in the set of real numbers. So, different thing we need to know about square roots. With fractions, we can't divide by 0, but with square roots, we can't take the square root of a negative number. So if any one of these numbers make the inside of this square root, it's called a radicand, you'll learn that in college, but if they make the inside of this square root negative, well, then the whole expression is going to be undefined. It's not going to have a real answer as you guys think of it. I won't be able to simplify it because it's basically something that doesn't exist. So I'm just going to pull out that middle and do 17 minus 4x and see if I can make this expression be negative. So what if I plugged this 5 in? 17 minus 4 times 5. 17 minus 20. Ooh, that would be negative. I'm taking away more than I have. Negative 3. So 5 definitely makes this expression undefined. So A is tempting, but A isn't the only one where I have 5 involved. So let's look at B. 17 minus 4. I already tried 5, so now I'm trying 4. So 4 times 4. 17 minus 4 times 4 is 16. 17 minus 16 is positive 1. I can totally take the square root of a positive number. This is not going to be undefined. B does not work. So I like A. Nice. Now, if I tried to plug in the negative numbers, this is tempting to a lot of students, but watch out. I'll just do it with negative 5 to show you. 17 minus 4 times the quantity of negative 5. When I'm multiplying this negative 4 times negative 5, right? We're supposed to multiply before we add, subtract. So when I'm multiplying, I'm going to treat this like it's negative 4 and negative 5, and a negative times a negative is a positive. So I'd end up with 17 plus 20, which of course is positive 37. It might be ugly here to take a square root of 37 since it's not a perfect square, but it's possible, all right? There is an answer. It is defined, and so those guys don't make sense. And yes, correct answer is A. Okay, so all that to say, you need to take note of this. You can't divide by 0. So if you have a fraction, make sure the denominator is not equal to 0 or it's going to be undefined. And you can't take the square root of a negative number. So if you have a square root symbol and the inside comes to a negative number, it's going to be undefined. All right, you guys, that was a lot. I realize that, but you're my experience level students. We're picking up that skill here of evaluating expressions and using it for some interesting applications. All right, you guys, proud of you. Happy learning.